Hey guys, so in this video we are going to talk about multi-market support. So let's get into it. Basically what we're going to cover is what the problem is with multiple markets and how we solve these problems in the least painful way possible. Now, you don't have to be in Europe or work for an international company or something like that to make this useful, because the fundamental thing is that it doesn't have to just be something as a country difference that can make this sort of mindset very useful. It is also very important to have this with you if you have things that will differ in implementation depending on either which environment you're running your code in. So if you're running different servers that cater to different customers, or let's say that you have different needs on behavior depending on where you are running your code or who's making the request. This is usually where this sort of thing becomes important. But for the intents of this demo, we're going to focus on markets, because when it comes to different languages and different countries, this is probably it's probably the easiest to digest. So the big problem that you're going to face is what we call permutations, and basically that is the fundamental, that's the big enchilada problem with having multiple markets or running code that is going to run in different countries, because each country has a different language, and each country is going to have different business logic that is going to depend on that language. It can be things like legal things, it can be differences in how the application has to work, because you have to do things in one way in one country and then another way in another country. There's so much complexity when it comes to supporting an application that needs to account for the country it's dealing with. So what I'm going to show you is based on how this is solved, like the basics of how this is solved in a few of my previous jobs. One of the jobs is this approach is used in systems. I would say pretty much all of the bigger systems are using an approach such as this. But from first-time experience, I can say that this works extremely well, even though the problem itself is really horrible, even with this. So what we're going to want to reach for in our toolbox of tricks that we have as developers is something we call dependency injection. Now, dependency injection, all that is basically that you create an interface for something, and then you under the hood inject code that is compliant with that interface. That's in essence what it is. And that sounds fancy, but I'll walk you through how it works. So here is my little server. And here we have some endpoints. We have a endpoint to get some translations. And then we have a few example endpoints here that I'm going to walk you through why I feel like these are bad ones. And then we have an endpoint here that's called format, and all it really does is that it takes in some type of a sum, like a number of some sort, and returns a decimal space, or like how many decimal spaces should we have. And then we have some endpoint here that just represents a way to make money. It's just a way to make that. It's just a silly little example. Make money. It's going to make money somehow. I don't know how, but that's what it's going to do. So this is an international product, which basically means that depending on who's making the call or in which environment we're running this, we're going to have differences in behavior, and this is the thing that we want to deal with. So let's start with a common example that I see that I will explain why I feel that this is very bad, and then we'll walk through like kind of this is really bad, and then there's a less bad thing, and then it's the thing, and then there's the thing that I think that you should be doing. So you probably have seen this at some point somewhere. This is usually like market is one way of doing it, but you probably have seen is test environment or something like that as well, where you have someone who is doing an if else or switch or something like that based on an environmental variable to check what they should do. Should this be a test code? Should this run the test code, or should it run the production code? Should it run this code, that code, etc., etc.? Now, the reason why I argue that this is really bad is because although this is solving the problem where we're figuring out from this code here that, okay, so in Denmark, Norway, and Sweden, we're going to add 2 decimal spaces to our sum here. that's great. And if it's none of these countries, we're going to throw an error of some sort. And we could, of course, extend this now and add other countries where we could add other conditions, such as say that, oh, we wanted to add Finland as an example, which is actually not here, I see. And maybe in Finland they want 3 decimal spaces or 1 decimal space, or maybe they want some other way of representing it, right? So we can extend on this. The problem here is that this creates a lot of duplication, because what you're basically doing is that you are copy pasting these statements over and over and over again all across the code base. So you're basically increasing the total amount of code you're writing, or the total amount of boilerplate you're writing, every single time you want to do this check. This is it's an easy thing to do, but it's also not that great. It's also very hard for you to figure out if you remembered to find all the places where you're making this check. You can make this simpler by, instead of using like this system where you're basically checking an environmental variable, you're checking an enumeration of some sort. Because then you can use exhaustive checks where the types, your compiler can basically tell you that, if you remove this default case here, then what you're basically doing is that the compiler is if you configure your compiler, it can actually tell you that, you have only covered a part of the possible permutations that you can deal with here. You need to account for the other cases as well. But this is one way of doing it. It will work, but I really encourage you not to do that. Then we have something that is slightly better, where instead of using an environmental variable that can be littered all across the entire place, we're moving everything into a configuration. And this is slightly better. So if we go in here, we can see here that we have some type of configuration concept. Now it's in the direction we want to go, because we already know that we need a way to distinguish between the different execution contexts, where, all right, right now we're running a Swedish server, or we're running a Danish version, or we're running an American version. It doesn't really matter. We need some way to capture that. And instead of adding like a bunch of if statements that checks an environmental variable like that, it's simpler for you to simply create a configuration file of some sort that holds this information. So here you can see that I have a few enumerations that checks the different markets, and then I have this config interface. And then I have a bunch of different configs. So let's say here in Denmark, we have this thing here where we're basically just adding in the configurations that are going to be applied in a Danish environment. So this is actually better, because here we're doing a switch statement, and we're actually checking if the market is, instead of using this global thing that can come from anywhere, we're actually narrowing down all of our configurations into one central location, so that we can actually check much more complicated things than we could if we just do this, because then basically we're forced to we're leaking out and duplicating information all across everywhere, instead of just having one central place where we're checking the same value. So this is slightly better. It's still not great, because we're still doing all of this duplication with all of these switch statements to check this logic. So what I'm trying to push us towards is to do something like this, where instead of thinking in the terms of, okay, this is my execution context, or this is where I'm running my logic, okay, which cases do I need to cover here? Instead of doing that, think in terms of an interface. Now, what do I mean by that? Well, it's very simple. Why would I need to, here in my logic here, figure out that I need to put a 2 in the toFixed function depending on which environment I am? That is completely pointless. I don't need to care about that here, because all I really need is to know that this value is going to be the correct value depending on which market I'm in. So this configuration here, although it's good for me to know that, this is which market it is, and have a central location where I know this is even better. So notice now that I'm still using a configuration, but here I'm checking the fraction digits. Like, I'm just checking what the number is. And if I go in here, this is just a number. And then we can check my different environments here. So here's going to be a 2. It's going to be a 2. I think it's a 2 all through, because I haven't bothered saying, in Sweden we're special. We want to have 22. I don't know. I hope that makes sense to you. So that instead of having runtime logic, or like in my business logic here, instead of having that trying to figure out inside of this logic here which value I need, I simply create a interface for that value, and then I reference that value in my code, and then this code doesn't have to care about what that value is. It doesn't. It trusts that the instantiation of this config object has been correct, and it trusts that this value is going to be the correct thing, because it's unimportant to figure out which market it is in this context. Now, this is a simple case where we're dealing with a value, but this also applies for logic. So if, let's say for the sake of argument, that we're dealing with something like making money. Well, making money is great, so let's have a look at how we were going to make some money in this scenario. So here I have a service where I have a Swedish money-making service, and then I have a general money-making service, because in Sweden we make money in a different way than everybody else is making money, for some reason. And dependency injection basically states that, okay, I am implementing a iMoney service interface in both of these concrete implementations of how to do this, and as long as they both of these instantiations or these classes are using this function, I don't really care how I'm going to make money from this. I just want it to work, if that makes sense, because they represent the same function, but they're going to do it in different manners. So in here, I'm just logging out, made some general money, but in the Swedish case, I'm checking, this market, that the configured market is Sweden, and then I'm going to say, made some Swedish money, otherwise I'm going to throw an error just because I don't want this logic to execute in the wrong context. So I can extend this now. I could do anything I wanted in here, and but the interface would still stay the same. And the power of this is that from this logic here now, I don't have to do this. I don't have to check which market I am and then check which instantiate each of the both the general money service and the Swedish money service, and then try to figure out here which one I need to use. I can just use this one because I trust that when I grabbed this money instantiated version of the money service, I got the right version. And the way that we make this happen is very simple. We use a pattern such as this. Let's see here. Here we are. This is the basics of how we can make it work. We simply have an instantiation function or a dependency injection handler of some sort that checks which market we're running in, and then we just pattern match, and we say, okay, this is what you may notice that the basic name for this pattern is a factory. So this is a factory function. It takes in a configuration, and it's going to return an instantiated version of one of the money services. And since they're both abiding by the general interface, all the code around the money service is going to work the same. Everything outside because the rest of the code doesn't need to know about which version it's using, because that is taken care of here. And this is extremely powerful, because now the interfaces and the usage of the money service is completely general. It doesn't you don't have to think about which market you are in anywhere else in the code. It's just happening here. This is extremely powerful. And it's the basic of a dependency injection. And let's look at this translation service. So I have a translation service that's not using dependency injection, because it doesn't really have to, because it's the same service regardless of which environment I'm in. It's always going to act the same way. So I don't have to create one Swedish version, one English version, and one Danish version, etc., etc. I can just use the same one. So when we're dealing with translations, the same sort of mentality applies. We can do this here as well. Like we could create get translations in a really bad way and come back to this problem where, okay, so now this translation service, it needs to look at the market, and then it's going to pattern match on the market. But that's what I'm trying to get us away from. I'm trying to get you to understand that the best thing is to minimize the surface of where you're trying to figure out which market you're dealing with, and simply have a interface or a placeholder that represents the the value that you want, and the code shouldn't have to care about which, like, how that value gets to where it needs to be. So as an example here, you'll see that getting translations, it's under the hood, it's using basically the same it's the same function, or rather it's the same structure to the function, and this function is the lowest level where you need to know which set of translations you need to get. So here you need to do the pattern matching. So here you're basically just saying that, okay, I have this locale here, and then you pattern match on which set of translations you actually want, and then of course you get a key. Like when you're in the other version, you're simply getting all of the translations. So if we have a look here, I've just created some dummies. These are just dictionaries where different translations exist. But I hope this makes sense to you. By encapsulating or by trying to push the places where I need to know which runtime environment I'm in or which language I need to the edge of my logic, all the other logic can stay completely generic, because they don't need to know which environment they're in. All they need to know is that, oh, if you call this function here and you give it a locale, no matter what locale that is, and you give it a string, you're going to get back a string, like in some language. You don't care about which language. The higher level abstraction doesn't need to care about which type of language it is at this level, because this is too early. It shouldn't have to care about it, either, because there's a nice little function that just abstracts away the concrete version, the concrete language that it's going to get back. Now, this is a very nice way to deal with a very ugly problem, and I'm very sorry to say that even if you do this, even if you start, as you can see here, I mean, even in this little example here, you'll see here that I have this config loader function that loads in my config, and it is actually checking the environmental variable, because this is the only place ideally where I want to check that environmental variable. And then I have a bunch of different configs that gets instantiated depending on which market it is, and then it's just going to provide me with that config. So I just do this check once, and then I get the correct version. Now, that's great when I'm writing my business logic, but there's one scenario where this is really horrible, and that is from the testing perspective. So this, I'm sorry to say, there's no way around this, unless if you need to express that there is a fork somewhere, there's an if or an else or a switch or something like that, you need to test for every case. There's no way around it, because if, as you can imagine, you can ignore it if you don't care, but let's take the money example here. If I have two services that behave in a different way, then I need one test or one suite of tests to cover the general money service, and then I need one suite of tests to cover the Swedish case. And for every permutation that I get, I need more and more testing. So this approach that I'm showing you with using dependency injection, it just helps you abstract away the complexity of the logic, so you don't have to write as much boilerplate. But when it comes to testing, you still have to do something like this, where you're creating like a translation service, or you're creating different files with different specs or different unit test suites for the different services, and then you have to manually instantiate. Like, this is a very simple way of doing it, but you have to create one configuration for Sweden here, and you run your translations, and then you expect something to happen. And, well, I've been lazy here, but technically I would have had to create one version of a test for every permutation that I can have. And it gets really tricky with like making sure that, oh, should it be possible to have market Sweden and then have like a locale of Danish or something like that. There's so many like different permutations of a configuration that you can have, that you have to do something that we call, at least I believe so, you have to do risk-based testing, where you try to cover the cases as you kind of go along as best as you can, because you can't test for every, like, it's almost impossible to do exhaustive testing. You're going to have hundreds and hundreds and hundreds of different tests just to cover all the different permutations. But at least with this approach, you're going to stay away from having a lot of ugly boilerplate that messes up your code and because this gets really ugly really quickly, and it gets really complicated very quickly. So what I want you to take away from this is basically that when you're dealing with something like a multi-market situation where you have different languages or you have different approaches of dealing with, well, different configuration, different requirements depending on your runtime environment, then I would strongly advise you to not do something like this where you basically just write out the switch statement for every piece of logic that you want to create. It's much more efficient for you to create a config interface of some sort and then have multiple configuration files that represents the different flags or the different values that you might need in your logic, because that way your logic can stay very clean, such as in this scenario here, and you can also and then use dependency injection to load the right configuration module, such as this. You simply do this, the market check in one place, instantiate your config in one like immediately, and then that's it. And the same thing goes when you're creating different logic flows with different services and stuff like that. Create an interface that represents the operation that you want to take or make, and then create multiple versions that can encapsulate the different behavior. And then finally, you simply do the same thing. You just dependency inject, or you instantiate the correct service version depending on what your runtime environment is going to be. And then anything that doesn't need to be different depending on the market that you find yourself in, you can just keep as is. And that's always the best case. The less permutations, the better, but sometimes you can't get away from it. Have a great day.